Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students. Today we are going to start with class 9 science chapter number 12 study of sound. Topics that I am going to cover during this session are introduction to sound waves, velocity of sound waves, and different types of sound waves like audible, infrared, and ultrasound. Sound waves. Sound is a form of energy which creates the sensation of hearing in our ears. This energy is in the form of waves. A medium is necessary for the propagation of sound waves. Sound waves give rise to a chain of compression and rarefaction. The particles of the medium oscillate about their central or the mean positions in the direction parallel or perpendicular to the direction of the propagation of wave. This is the longitudinal wave that is shown over here in the picture. Here you can see the particles of the medium, they oscillate about their central or the mean position in the direction that is parallel to the direction of the propagation of the wave. The propagation of the wave is in this direction, that is towards the right direction, and the particles, they are also moving about their mean positions in the direction that is parallel to the direction of the propagation of wave. So this wave is called longitudinal wave. Here you can see the compression and the rarefaction. We have seen that sound waves give rise to a chain of compression and rarefaction. Here you can see there is a compression in the sound waves. It is compressed, whereas over here you can see the rarefaction. The distance between the waves is more. On the other hand, in the waves that are created by, for example, a stone that is dropped in the water, the particle of the water oscillates up and down. So these oscillations are perpendicular to the direction of the propagation of wave, and these waves are called transverse wave. It is shown over here in the picture. You can see over here the particles of the medium, they propagate in the direction that is perpendicular to the direction of the propagation of the wave. So such waves are called transverse wave. Here you can see this point is indicated as crest and this is trough. Let us understand what is crest and trough. Now here you can see the purple line is indicating the sound waves. Crest on the wave is the point with the maximum value of upward displacement within the cycle. Starting from this point, the wave is starting and it is again reaching over here, right? It is going in the upward direction, going in the downward direction, and again reaching at this point. So this is called one cycle of the wave, starting from here to here. So crest is the point on the wave with the maximum value of upward displacement, and trough is the point with the minimum value in the downward direction on the cycle, right? So crest is the highest surface part of the wave and trough is the lowest surface part of the wave. And amplitude, the number of molecules displaced by the vibration, it creates the amplitude of the sound waves. It shows that how forceful the wave is. Here in this picture also you can see the amplitude of the wave. It indicates the maximum value of the pressure or the density. Let us understand frequency and wavelength of a sound wave. Picture shows a transverse wave where the distance between the adjacent identical parts of the sound wave is called the wavelength. Adjacent identical part means over here we can say the first crust and the very next crust. These are the two adjacent identical parts. So the distance between the two adjacent crusts is called the wavelength, or I can say the distance between the two adjacent trough also, because these are also the identical parts. So the distance between the two adjacent trough is also called the wavelength. The time taken for one oscillation is called the time period. One oscillation means to complete one cycle starting from one crust, then again reaching towards the adjacent crust. So this is the one cycle. So time taken to complete one cycle or time taken to complete one wavelength is called the period. Over here, the time taken is 1 second from the first crust to the next crust. So the period is 1 second. Whereas frequency is the number of cycles per second. Here in 1 second, only one cycle is completed. So one cycle per second, that is equal to 1, and unit of frequency is hertz. So over here, this transverse wave is having the frequency of 1 hertz. Value of frequency determines the pitch of the sound. Let us understand this. What is frequency? Frequency is number of cycles in 1 second. Over here, you can see the number of cycles completed in 1 second are more. So this sound wave will have high frequency, or in other words, I can say it is high pitched sound. Whereas this sound wave has less number of cycles completed in 1 second. So this sound wave will have low frequency as compared to the first one. So I can say that it is low pitched sound. Whereas amplitude of the sound wave, it determines the strength or the loudness. Here you can see this is the amplitude. So it indicates that how forceful the sound is, how loud the sound is. So amplitude determines the strength or loudness, whereas frequency determines the pitch of the sound. Let us understand the relationship between the wavelength and frequency. Two sound waves are shown over here, one with a long wavelength and one with a short wavelength. The sound wave with long wavelength will be of low frequency because the number of the cycle completed in 1 second will be less as compared to this one. Over here you can see the number of cycles completed in 1 second will be more. So short wavelength sound wave will be of high frequency. Velocity of sound. We know the formula for velocity, that is equal to distance upon time. So it will be lambda by t. Here lambda is the wavelength of the sound. It is the distance travelled by the sound wave in one time period, that is t. So v is equal to lambda by t. We can write it like this, lambda into 1 upon t. And we know that 1 upon t is nu, that is the frequency. This symbol is called nu. So we get v is equals to lambda into nu. That is, we can say velocity is the product of wavelength and frequency. In any medium at fixed physical conditions, the velocity of the sound of different frequencies is very nearly the same. The velocity is highest in the solids and least in the gases. It increases with an increase in the temperature of the medium. Velocity of the sound in the gaseous medium, it depends on the physical conditions like temperature, density of the gas and its molecular weight. Let us see this relationship. The relationship of velocity with temperature. The velocity of sound is directly proportional to the square root of the temperature of the medium. This means that the increase in the temperature 4 times doubles the velocity. The velocity of the sound is inversely proportional to the square root of the density. Thus, increasing the density 4 times reduces the velocity to half of its value. The velocity of the sound is inversely proportional to the square root of the molecular weight of the gas. Thus, increasing the molecular weight 4 times reduces the velocity to half its value. The limit of hearing of the human ear are 20 Hz to 20 kHz. That is, the human ear can hear the sound of the frequencies in this range only. that is from 20 Hz to 20 kHz. These sounds are called audible sounds. So this is the range in which we can hear. Sound waves with a frequency too low for the human ear to hear are called infrared. That is the sound which is having the frequency below 20 Hz. Whereas the sound waves with the frequency too high for the human ear are called ultrasound. That is the sound with the frequency over 20 kHz. Animals such as whales, elephant and hippopotamus, they use infrared sound to communicate over distances. Whereas animals such as dogs, bats, birds and insects, they can hear ultrasound. Let us understand infrasound in bit more detail. Any sound below 20 Hz is known as infrasound. The human ear is not sensitive enough to detect either of these two types of wave. However, many other creatures are. Infrasound is very useful as it travels very long distances and can be used as a method of communication between the animals and the way of detecting earthquakes and volcanoes. Ultrasound. It is opposite to that of infrasound. Here the frequency is too high pitched for human hearing. According to the sources, women are capable of hearing slightly higher frequency. Animals such as bats, cats and dogs, they use ultrasound to communicate and survive. Bats use ultrasound waves with a frequency up to 100 kHz to move around and hunt. The Italian scientist Spallanzani was the first to discover a special mechanism that is present in bats. He covered various organs of bats like the eyes, ears, nose, etc. one by one and allowed them to fly in the dark, thereby discovering that how they can fly easily in the dark. He found that the bats with their ears covered began to collide with whatever came in their path, even though their eyes were open. They were of no use to the bats. Hence, he discovered that their ability to fly in the dark depends on their ears and not the eyes. As bats fly, they send out short pulses of ultrasound waves, about 200 pulses per second. Ultrasound waves reflect off objects and return the bat's ears. The time it takes for the sound to return to the bat lets the bat know that how far the object is. Uses of ultrasound waves. It is used in sonar, that is sound navigation ranging, which is a technique that uses sound propagation to navigate, communicate with, or detects the object on or under the surface of water. It is also used for the communication between ships at sea. It is used for cleaning very small objects like the parts of watches. It is used for imaging human organs, that is sonography. It is used for detection of defects in metals. It is also used in surgery to remove cataract and to break the small stones into fine grains formed in the kidney. It is used for drilling holes or making cuts of desired shape in material like glass. Ultrasonic wave is used for cleaning industrial equipments. It is also used to sterilize the liquid like milk by killing the bacteria. So there are several uses of ultrasonic waves. This is all for today's session. Thank you so much.